So we're going to do, today's the 19th. We're going to be doing types of reactions. Today we're going to be covering synthesis, single replacement, and combustion. And then at the end, I'm going to give a couple sample problems so that you can try them out. The challenge with these types of reactions is crisscrossing and reforming the compounds and then balancing the equations. So there's basically like 3 or 4 parts. The first part is what type of a reaction it is. Then you go and look up, how do I predict the products? Then you have to crisscross in the appropriate way to make the new products, and then you have to balance the equation. Plus, you have to go and figure out the states of matter. So I'm going to show you how to do that. Now, always kids say to me, like students always say to me, they take so long. Like each problem takes so long. And so my answer is always, well, are you busy doing something else in chemistry class besides a chemistry problem? Like this is a chemistry problem. Yeah, they take a long time in the beginning. But the more that you get to know, the more familiar you get to know with the process, they take shorter and shorter and shorter. So, for example, if you know that all nitrates, ammonium, and first families are soluble, then you don't have to look it up. And so they move very fast, much faster. So we're going to add right now onto your foldable, we're going to add that all halogens, and where are the halogens on the periodic table? Anybody know? So halogens are family 17. Family 17, right? They're the family 17 gases. All halogens except fluorine are soluble. And what soluble means is that they dissolve in water. Exceptions are silver, mercury, and lead. So, in other words, except for fluorine, any compound that has a halogen in it is soluble unless it's attached to silver, mercury, and lead. So if I go down here and I look at chloride, they're all S's all the way down here for soluble except for silver, mercury, and lead. Those are all I's for insoluble. Okay? So we just make a general rule that they're all soluble except for silver, mercury, and lead. So if you know these few, you're going to speed up your process substantially. Okay? So everybody wrote that down? We've got that? All right, let's move on. So we're going to start today with synthesis. And before we start, we're going to make a quick list over here of our diatomic elements. And that way, we'll be sure that if we have to write them, oops, that's an F. F. So chin fob. If we have to write our diatomic elements or look them up, they'll be right there for us to write them or look them up. Now, when we look to identify, if I look on my foldable, how do I identify synthesis? We're going to look for only one product. We're going to look for 2 elements combining. And we're going to look for 2 types of reactant combinations. One would be a nonmetal and an oxygen plus water. And the second type would be the metal, oxygen plus water. So these constitute a synthesis. And so you can look at these and say, oh, okay, now I know it's a synthesis. And then you open up the folder and you look at the products. And so that's what we're going to address today, is how do we write our products. So our first example is going to be copper, which is a solid, and you would be given this in the problem, right? Well, maybe not. But if you weren't given it, you would look on the periodic table because it's just copper metal. You would see, oh, copper, it's black. It's a solid, right? And then plus O2. And what's the state of matter for oxygen? It's a gas. Excellent. Thanks, Michael. It's a gas. Good. All right. So I have a metal. So now I'm going to label this as, you don't have to, but so we see what it is. It's an A. It's a metal because in your foldable, remember A's and B's are metals and X's and Y's are non-metals. So this is a metal and this is a non-metal. So this is an A plus X. So if you look here, A plus X yields AX. A metal and a non-metal yields the metal and the non-metal combined. So I'm going to tell you now, so that so you don't have to figure it out. I'm going to tell you that this copper is plus 2. Because copper can either be plus 2 or plus 1. So I'm telling you it's plus 2. So now the answer here is going to be copper and oxide combined. So I have to crisscross that. So I'm going to take my copper. And what's the charge on oxygen? -2. Okay, that should have been instantaneous, right? Because -1, -2, right? And then we're going to crisscross these, and that's going to give us Cu2O2, so we're going to reduce. So my compound here is going to be CuO. Now, I need a state of matter on this, because we need to put in states of matter for everything. So I'm going to go to the back of my foldable, and I'm going to go to copper 2 right here, and I'm going to go over to oxide, and there is an I there. That I means insoluble. So I go down to the bottom, and here it says at the bottom, insoluble, and in parentheses is an S. That means solid. I know this is confusing. I am aware. This is the way the charts are written, okay? In the equation, we don't put an I for insoluble. We put an S for the state of matter, which is solid. All right? So our states of matter are AQ for aqueous, or S for solid, or you can write a G for gas, or an L for liquid. Those are your states of matter. All right? And this tells you what the state of matter is. If it's an I, it's insoluble, which means if you put it in water, it's going to just sit at the bottom. It's not going to dissolve. If it's an AQ, then it's soluble. It's an S, see here, S, soluble, AQ. That means that if you put it in water, it's going to dissolve. All right? So the question is here, what will the states of matter be in water? Unless it's just an element sitting there, and then it's not in water. It's just an element sitting there, all right? So this is going to be a solid because it says I on the chart. The last thing I need to do is balance this equation. I have 2 oxygens here because oxygen is diatomic. So I have 2 oxygens here. I have 1 here, so I'm going to put a 2 here, and that gives me 2 coppers. I'm going to put a 2 here, and now I'm finished. Wow, that took a long time. Yup. That's what you're doing in chemistry right now. Every problem takes a long time. Here we go. Letter B. Letter B, SO3, which is a gas, plus water, which is a liquid. Okay, so now I look, and this is a non-metal oxide. So that identifies this as a synthesis reaction. Okay? So, I'm going to write this in so you can see it. AO plus H2O. That identifies it as a synthesis. All right? So now I'm going to go inside and look at my products, right? And here's my products. I get H, X, O, and the O has a +1 on it. That means however many there are here, there's going to be one more here. So all I'm going to do is I'm going to take the XO, I'm going to move it over to the hydrogen and crisscross, but I'm going to add one oxygen to that. So let's see what happens. So I'm going to get H, which is a +1, right? And then I'm going to get SO4. Oh, SO4. See, SO3 +1, right? SO4. What is SO4? Sulfate. And what's the charge on sulfate? -2. All right? So that's why I had you memorize those polyatomic ions, so that they would be helpful, right? And they're on your periodic table, which I know you don't have in front of you right now, but they're on your periodic table, right? All right, and then we crisscross, and I get H2SO4. Now, what's the state of matter for that? Well, I go here and I look at hydrogen, which, by the way, is a family 1, right? And it's not even, oh, here it is. Yep, family 1. And oh, look, it's soluble all the way across. Why? It's family 1. All first families are soluble. No exception. Aqueous. And this is balanced. So I don't even have to balance it, okay? Letter C. Iron, which is solid on the periodic table, plus fluorine, which is diatomic, and it is a gas. So this is a metal plus a nonmetal. They're going to come together. So I have iron. I'm telling you this is going to be a +2. All right, I'm telling you this because it could be 2 or 3 because it's a transition metal. So I'm telling you that. It's given. All right, so that means this is Fe +2. And what's the charge on fluorine? Yep, -1. Good job. And then I'm going to crisscross. So I'm going to get FeF2. Now I need the state of matter on that. All right? So I go to the back and I look it up. But the thing is, it's not here. Oh, is it? Nope, fluoride's not here. So what do? I go up here and I look. All halogens except fluoride are soluble. So what does that mean about fluoride? It's not soluble. I go down to the bottom and I see insoluble is an S for solid. So fluorine, there it is. So if you memorize that rule, all halogens except fluorine are soluble except for silver, mercury, and lead. Those heavy metals, that's the thing. Those heavy metals make it so that those halogens are insoluble. Silver, mercury, and lead. There are other heavy metals that also are insoluble when attached to halogens, but these are the only 3 that we work with. Okay? So all halogens except fluorine are soluble, and then silver, mercury, and lead will make them insoluble. All right? Okay, and now I just need to balance. So I have 2 fluorines here, 2 fluorines here. Oh, it's balanced. Okay, good. All done. Questions on how to do this? Yes? Yeah, so on your foldable, if you open it up on the inside, A's and B's are metals, X's and Y's are nonmetals, and O is an oxygen, and H is hydrogen. So the reason I do this is because the reason that this is done this way is because when you get to a double replacement, it says they're two metals. And if I just said non-metal, you wouldn't understand that, like, they're two nonmetals, right? So, or two metals. So it's easier to say A and B are both metals than I can have two metals in one equation. Okay?
So O is oxygen. Why do you do X or on A? Why do you do X under oxygen?
Oh, because in this case, this is a metal and a non-metal, or it could be O, but in this case, it's a synthesis. So it's not acting as oxygen. It's just acting as a non-metal. But here, down here, it's acting as a non-metal and oxygen. So when you're looking at a synthesis, here are your choices. Your choices are a metal and a non-metal. A metal and a non-metal, a metal oxide or a non-metal oxide, or a non-metal and a non-metal. So nowhere in a synthesis do you have a metal and an oxygen, right? So to make this fit, but it is two elements. Does that make sense? So it is two elements. So it is a synthesis. So how am I going to fit this into the pattern? So this fits into the pattern. It's a metal and a non-metal. Does that make sense? That's a really good question, Michael.
On number 2, if I keep SO3, it's sulfur oxide, right?
Mm-hmm. SO3?
Yeah.
Sulfur trioxide, yeah.
I do tell that S was an A.
Oh, it's a X. Thank you. Just from working too fast, it's an X. I have it as an X on my other copy. I just worked too fast. Yeah. Good job. Way to pick apart the teacher. Well done. Keep at it. All right. Single replacement. Here we go. A. You're going to need for this one the activity series, right? The activity series is found here, right in here. It's called the activity series of metals or nonmetals, and I think I called it the activity list or the activity series, okay? All right, here we go. So this one is identified as an element and a compound. That's what you need, an element and a compound. So let's start with an example. A. We have sodium, which is an element, so on the periodic table, that element is a solid, plus magnesium iodide. So you can look here. Iodide is in family 17, so all halogens except fluorine are soluble. Exceptions are silver, mercury, and lead. Not silver, mercury, and lead. Nope. So this is going to be aqueous. Because iodide is a halogen and not silver, mercury, or lead is attached to it. So I don't even have to look it up, right? Okay, next. This is what happens in a single replacement. I have a positive metal here, and I have a positive metal here, and I have a negative nonmetal here. So the sodium is going to try and replace the magnesium. That's what it wants. It wants to kick out the magnesium and take the iodide. That's what it wants to do. It wants to take the iodide in this reaction, all right? So I call this list the kick butt list, all right? So it's sort of like sodium and magnesium iodide get to a party. And sodium, looking across the room, winking at iodide, sodium wants the iodide. And so sodium is going to, love this phrase, duke it out with magnesium. 1920s, duke it out. They're going to duke it out. The question is, who's going to win? The prize is the iodide. So who's going to win the prize? All right? Well, we know who's going to win the prize because we look at the kick butt list. Okay? So the question is, who's higher up? Who's ever higher up on the kick butt list wins the prize of the iodide. So we look, magnesium is here and sodium is here. Oh, too bad for magnesium because sodium's going to win. So that means sodium is going to beat up magnesium and take the iodide. So that means that in the products, remember, crisscross, we have to make a new compound. So I have sodium. What's the charge? +1. And iodide, what's the charge? -1. I crisscross, and I get sodium iodide. I go to get the state of matter, and what I see is I don't have to go very far because first family, no exceptions, is always soluble. No exceptions. And sodium is first family. So without exceptions, it is always soluble. Plus, magnesium is going to now be at that party by itself. Sad magnesium. On the other hand, you know what? Frankly, magnesium's probably better off. So now I look up at the periodic table and I see magnesium by itself is a solid. Okay? Now all I have to do is, what's my last step? Balance. I'm going to balance the equation. So I look, I see I have 2 iodides here and 1 here. So if I put a 2 here, now I have 2 iodides, I have 2 sodiums, and now I'm balanced. Well, Ms. Paxton, that took a long time. Sorry, didn't mean to interrupt the volleyball game. No, you're in chemistry. You're in chemistry. That's what you're doing. These take a long time until you get good at them, all right? And then they don't take so long. Here we go, letter B. So in letter B, same party, but now sodium iodide, which we know is aqueous, meets up with magnesium later on. Okay, it's a rematch, a reduke. They're duking it out. Magnesium wants to take the iodide away from sodium. Now, we know who's going to win this match, don't we? Right? Okay, because sodium is still going to win. So what we do here is we write NR for no reaction. That's what that means. No reaction, because bottom line is the products are going to be the same as the reactants, so literally nothing is going to happen here. Okay? All right. Questions. You figure out positive or negative, whoever is the double, because obviously a positive can't replace a negative. So a positive is going to replace a positive, and a negative is going to replace a negative, okay? All right, last, combustion. We're going to do one of these. Okay, here it is. You are given C10H8, which is a solid. And then your problem will look like this. Okay, how are you going to fill that in? All right. So according to our foldable, the products of a combustion are O2, which is what state of matter? A gas. And then we're going to add CO2 as a, sorry, not the products. Combustion is the burning of the hydrocarbon in the presence of O2. And then we're going to add the carbon dioxide as a product and the water as a product. The water is a liquid or a gas, depending on the situation, and the carbon dioxide is a gas. And so now all we have to do is balance it. So we're going to balance this equation, and that's how we do a combustion, okay? That'll do it for yours. Now, questions on anything that we did here? Remember with the single replacement, because we're going to do 2 sample problems now. Remember with the single replacement, you need to label positive, positive, negative, and then the 2 positives are the ones that are going to duke it out. A simple way to remember that is when you go to your activity series, your metals are on the one list and your non-metals are on the other list. So if you have to go to 2 different lists, there's no way to know who's going to win. Does that make sense? Both of your fighters should be on the same list. So if you say, oh, it's going to be sodium and chloride duking it out, and you go, sodium is here, and uh-oh, that's a problem. Because they're on 2 different lists. They're at 2 different parties. You must have the wrong people duking it out. Does that make sense? All right, so go back and figuring it out again. Okay? All right. Okay, so here are your sample problems. Here's your first one. I want you to write this down and try and complete this. Ignore this dot. That was a mistake. Okay, what kind of a problem is it who's going to replace who, who's going to do what, crisscross, balance. That's what I want you to do. And number 2, aluminum plus iodine. Okay, so let's take a look at what we got. So, potassium is positive, bromine is negative, and fluorine is negative. So what's going to switch places? Fluorine is going to try and kick bromine's butt. The negative and the negative. All right, the 2 non-metals, right? So this is A, X, and this is Y. 2 non-metals. So when we look, we're going to look at the non-metal kick butt list, and we see fluorine is at the top of it and bromine is farther down. So fluorine is going to win. So I'm going to take potassium and fluorine, and I'm going to crisscross. And my products are going to be potassium fluoride plus bromine, which is diatomic. I know this because I had my list there. Now I look up bromine on the periodic table, and weirdly, bromine is one of the 2 liquids on the periodic table. Next, I look up potassium fluoride, and it turns out potassium fluoride is the exception to the halogen rule. But potassium is in the first family, and they are always soluble, no exceptions. So this is aqueous. Now I'm going to balance 2 bromines. Oh, I'm just going to put a 2 here and a 2 here, and then I'm balanced. Yes.
Can you move the paper up a little bit?
Oh, sorry. I'm sorry. There you go. Now, for the next one, this is a combination, and so I'm going to put these 2 together because this is a metal and this is a non-metal. So aluminum, and I'm going to count over, plus 3, plus 1, plus 2, plus 3. And iodine, which is minus 1, and I crisscross. So my product is AlI 3. When I look for the state of matter, what I see is that halogens are all soluble except for, and it is not an exception. Yes, Michael?
When you crisscross in the first one for K and F, there was a 2.
On the F?
Yeah, what happened to that?
That's why I balanced it. Right? It didn't disappear. When I crisscross, I have to crisscross correctly, and then that's why I balance it, so I have 2 F's on each side. All right, so in this case, I'm going to have to go to 6 on the iodines, right? So I'm going to put a 2 here, a 3 here, and a 2 here. Homework